Oh, hey, didn't see you there. Wasn't planning on doing this tonight, but I guess you're here, I'm here, might as well do some math. So, good morning. Welcome to another exciting day of pre-calculus. Now, what we've got in store today is last time we hung out, watched a video. I don't know, keeps freezing on me. Last time we hung out, did a video, we were working on our conic sections. If we take a cone, rotate it, and slice our cone in different ways, we get different shapes. So today, we're going to pick up from where we were looking at circles, and we looked at the standard form of a circle, given a center, given the radius. We looked at the general equation of a circle and completing the square, turning it in so we could easily find the center and the radius of a circle. Today, we're going to take advantage of one of these unique properties that, given any 3 points on a Cartesian plane, we can find a unique equation of a circle that goes through those 3 points. So what we're going to do today is a little bit of reprise the ideas of the circle, work through our calculator, and see what happens. So I'm going to go over to my notes over here. Here's where you should be picking up, trying things out, following along as well, and then there's a little bit of practice that's going to go along with this. So over the notes, we have a reminder that our circle is our conic section. We can create that by taking a plane, slicing through a cone perpendicular to the axis of rotation. Now, we know from past experience that a circle is a set of all points equidistant from our center point. That distance would be our radius there. Now, we've got the standard equation of a circle, x minus h squared plus y minus k squared equals r squared, or hk is the center of the circle on the coordinate plane, and r is the radius of our circle. Now, if we open that up, multiply that out, we get the general equation of a circle, x squared plus y squared plus ax plus by plus c, where a, b, c combine in ways to give us the hk. So if we multiply that out, distribute, we can turn into that. We looked last week at using completing the square to turn from general equation of a circle into the standard equation of a circle, where it is easier to identify the bits. Now today, we're going to take the idea that there is a unique circle that passes through any 3 non-collinear points, those being 3 points that are not all in one line. So here's our task. We want to write the equation of a circle that passes through those given 3 coordinates. Looking over at a graph, we want to come up with an equation of a circle that hits those 3 points. The reason we can do this is we're going to take advantage of the general equation of a circle. Now there is x squared plus y squared, but there are 3 missing variables there, a, b, and c. 3 variables, 3 coordinates, you got it. We're going into a system of equations. So the way we're going to do this is, first off, we're going to create a system of equations by substituting each coordinate into the general equation of a circle. I'm going to take that 4, 2, 7, negative 1, and negative 1, negative 3, substitute it in. That gives us these values. Notice each xy gets substituted in, and we still have our a, b, c. I'm going to take those 3, I'm going to manipulate them so that I isolate the a, b, c. Not necessarily isolate the a, b, c, but I'm going to separate the constants, the 4 squared plus the 2 squared, from the variable terms, the 4a, the 2b, and the c. That's going to give us a system of 3 equations where we've got a, b, and c. I'm being careful to write this so my coefficients, or excuse me, the variables, line up in columns, and we have the constants on the other side. I got this by 4 squared plus 2 squared multiplying, subtracting it to the other side. Multiplying, subtracting my constant to the other side. Now, we've got a system of equations. We could do this by hand. We could graph in 3 dimensions. Whatever we're going to do, we need to solve our system of equations. Find those values for a, b, and c. And of course, we've spent some time on it. I'm going to recommend using our matrix algebra, our systems of equations used by matrices. I'm going to go into the calculator. Oops, didn't want that one just yet. So I'm going to go into the calculator. Now, just a reminder that over in the calculator we can use matrices to solve a system. Going to second matrix, over to math, I'm going to scroll to RREF, our reduced row echelon form. Now we're going to do RREF for the matrix, the coefficient and variable solution matrix that we have. I'm going to get that. Alpha zoom pulls up our matrix menu. I want a 3x4 matrix. I'm going to enter our coefficients and our solutions. And this will solve our system of equations. So we solve that A is -6, B is 4, and C is -4. Going back to my notes. There we go. Hey, surprise, it was like it's already set up. So we solve for A, B, and C. I'm going to take that A, B, and C. I'm going to substitute them back into our general equation of the circle. So where we before had just our variables A, B, C, I'm going to keep it with X and Y, but substitute in A, B, and C. Now, what's our center? What's our radius? Like last week, we're going to take this and rewrite this in standard form so that we can easily identify the center and radius of our circle. So we're going to rewrite this by completing the square. So reminder, we're going to take that, I'm going to collect the x terms, I'm going to collect the y terms, I'm going to move the constant to the other side of our equation. We need to fill in those blanks so that we can complete the square, so that we can turn this into a perfect square factor. X squared minus 6x plus something, those three pieces will be a perfect square trinomial. Y squared plus 4y plus something would be a perfect square trinomial. And we saw last week, we're going to take that coefficient of the linear term, divide it in half, square it, and add that value. So as an example, if I take that -6, I'm going to cut that in half, giving me -3. I'm going to square -3, giving us +9. I'm going to add 9 to this spot. I'm going to add 9 on the right. So we've got x squared minus 6x plus 9. There I've added 9 to the other side as well. I've got y squared plus 4y plus 4. I've added 4 to the right as well. That turns this into perfect squares. So now we can factor, and we've turned this into standard form for the equation of a circle. That gives us the center and the radius for our circle. Now let's take this, go back into our graph, see, did it work? So here we have our 3 coordinates. If we type in our equation, it's beautiful. Hits those points perfectly, almost like it was set up to work out. So that's what we have. Taking any 3 points, we can write the equation of a circle that passes through those coordinates. Try it out on your own now.